Hello, so today we will be doing the simplex method. This is a method for solving an LPP. It works for any number of variables that you have. If you remember the graphical method, you can do it only when the LPP contains only two decision variables. But this simplex method, it works when there are many variables. Okay, so let us see. Okay, so the question is solve the LPP, okay, given the question by the simplex method. If you have to solve the simplex method, if you have to solve an LPP by simplex method, then you will have to follow this algorithm that I had given you. Okay, so the first step of the algorithm, if you notice, okay, this is the algorithm that I'm talking about. Okay, so the first step is convert the LPP into standard form. Okay, so if we convert into standard form, you will have this one. Okay, so the LPP in standard form is max z equal for x1 plus 10 x2 plus 0 s1. We have added in the slack variables s1, s2, and s3 subject to the constraints. The constraints remain as they are, but if you notice, the inequalities have been converted into equalities in the standard form. Also, if you notice the right side of equation 1, equation 2, and equation 3, 50, 100, and 90, they are all positive. So that is required for the standard form if we have to solve it by simplex method. Okay, so once you do it by, if we have converted into standard form, which means that we are done with step number 1. Next, what we will do, okay, you notice the algorithm. It says that we have to obtain a basic solution. Okay, so let us see. How will we obtain a basic solution for this? Okay, how will we obtain a basic solution for the LPP? If you notice, we have 5 variables. We have 5 variables and we have 3 equations. Okay, so how will we do it? We will choose 2 variables as non-basic. Okay, so you can choose any 2 variables as non-basic variables. It will be simpler if you choose x1 and x2 as non-basic variables. Similarly, you can choose with any variables, but it is easier if you choose x1 and x2 as non-basic variables. So if you choose them as non-basic variables, their values will be equal to 0 initially. Okay, so now that we have got x1 and x2, just substitute this one and equation 1, 2, and 3. Substituting in 1, 2, and 3, we will be having, if you notice, we will be getting s1 will be equal to 50, s2 it will be equal to 100, and s3 it will be equal to 90. Okay, so after substituting, we have got this. So because we have chosen x1 and x2 as non-basic, so s1, s2, and s3, they are the basic variables. Therefore, basic variables, basic solution is xb, 50, 100, and 90. Okay, so this is the basic solution. Now, what do we need to find? If you notice, we need to find the matrix B. Okay, what is the capital matrix B? Okay, B, it is the basic matrix. So S1, S2, and S3, they are the basic variables. So if you notice the standard form, so B, it will be equal to 1, 0, 0, 0, 1, 0, 0, 0, 1. How did I get this one? Just take a look at equation 1. Take a look at equation 1. Coefficient of S1 is 1, coefficient of S2 is 0, coefficient of S3 is 0. Similarly, take a look at equation 2. Coefficient of S1 is 0, S2 is 1, and S3 is 0. Similarly, from equation 3, we will have this. Okay, now that we have found B, we can now find B inverse. B inverse, this is the identity matrix. So if it is the identity matrix, the inverse will be equal to B. Okay, this is very important. Okay, sometimes B may not be the identity matrix. In that case, you will have to find B inverse, okay, by finding the inverse of the matrix. But over here, since it is the identity matrix, it is very simple. After finding B inverse, what will we do? We will find Y1. It will be B inverse. Just take a look at the first column of equation 1, 2 and 3. The first column, it is 2, 2, 2, right? But B inverse, it is the identity matrix, which is B, so it will remain as 2, 2, 2. Okay, it will remain as it is. Okay, just multiply B inverse with this matrix, you will have this. Similarly, you can find out Y2. It will be B inverse, the second column will be 1, 5, 3. Again, it will remain as 1, 5, 3. Similarly, you can find out Y3, Y4, Y5. Y3, it will be 1, 0, 0. Y4 will be 0, 1, 0. And Y5, it will be 0, 0, 1. Okay, so we have found Y1, Y2, Y3, Y4, Y5. After finding all this, now we can go to the first simplex table. Okay, let us see. Let us see the first simplex table. How will it look like? Okay. So just remember these values that we have put in. Okay. We will need them again. Okay, but also remember that S1, S2 and S3, they are the basic variables. So now let us just fill the table. This is the initial simplex table that we are talking about. Okay, so after doing all that, we can fill in the simplex table. If you notice over here, what are we having? We are having Cj. What is Cj? It is the coefficient of z in the objective function. Okay, if you notice over here, the objective function is 4x1 plus 10s2 plus 0s1 plus 0s2 plus 0s3. So Cj is the coefficient. Over here we are having Cb, which is the cost vector. Okay, we will get to that. The basic variable, okay, we have found that it is S1, S2 and S3. Just take a look. Okay, so we have filled in S1, S2 and S3. Now what we will do, okay, we will fill. Okay, so over here they are the basic variables x1, x2, s1, s2, s3. They are all the variables correspondingly. Okay, we are having the coefficients. Now we are having y1, y2, y3, y4, y5. You need to remember how the shape of this table looks like. xb, it is the basic solution, and over here the ratio. Okay, you need to remember. And at the bottom part, you are having zj and zj minus cj. Okay, do not worry, we will get to this. Okay, but now we can actually fill in this table. Okay, so now I won't be needing the question anymore. Okay, maybe I will need it. So what can we do? We can fill the cost vector. The cost vector, remember, they are associated with the basic variables. That is why I've written them side by side like this. The coefficient of S1, it is 0 in the objective function. The coefficient of S2, it is 0. The coefficient of S3, again, it is 0. Okay, Y1 we have found out to be 2, 2, 2. Again, Y2 we have found out that it is 1, 5, 3. 1, 5, 3. Similarly, Y3 we have found out to be 1, 0, 0. 0, 1, 0 over here. 0, 0, 1. And XB, xb it is the solution. Okay, we have found that one out as well, which is 50, 100 and 90. This ratio we will fill in afterwards. Okay, but now let us compute the things that we have. Okay, so after finding all this, what you need to find now is zj. Zj you will have to find out. How will you find zj? It will be, if you remember, it says something like this. Okay, zj, if you take a look at the algorithm, it says cb transpose yj. Remember that j denotes the column. Okay, so y1, y2, y3, y4, y5, we are having 5 columns. So similarly, j will range from 1, 2, 3, 4, 5. Okay, j will be equal 1, 2, 3, 4, 5 over here in our case. What about I? We are having 3 rows, so I will be 1, 2 and 3. Okay, so some of them will denote something like this. This one they will say xbi. Okay, this one will be xb1, xb2 and xb3. Similarly, this one will be cb1, cb2, cb3. This one, if you have to denote this one, you can say this one as, this entry will be y. It belongs to the first row and the first column. This one belongs to the second row. So sorry, the first row and the second column. So y12. Similarly, you can denote this one as y13, y14, y15. This one you can denote it as y21, y22, y23, y24, y25, and similarly the rest of the entries. Okay, so that is concerning about the notation. Okay, so now let us find out what is CP transpose yj. CP transpose, it is 0, 0, 0. Okay, it will become a row times yj. Okay, so sorry, it's out. Okay, CB transpose, it is 0, 0, 0. Y1, now that you have to find, this one will be Z1, Z2, Z3, Z4, Z5. That's why I'm denoting it by Zj. So Y1, it will be 2, 2, 2. If you multiply this one, how will you do it? Multiply them as matrices. 0 into 2, 0, plus 0 into 2, 0, plus 0 into 2, 0. You will get 0. Okay, so this first entry over here will be 0. Okay, but actually you don't even need to remember this. Okay, you can really do it in the table only. 0 into 1, 0, plus 0 into 5, 0, plus 0 into 3, 0. If you add all of them, it will be 0. Similarly, to fill the value over here, 0 times 1, which is 0, plus 0 times 0, which is 0, plus 0 times 0, 0. So over here will be 0, 0. So this is what we are having. Now what will we do? We will calculate Zj minus Cj. You can even fill this one over here. Okay. Okay, it's not required. Okay, maybe we can calculate later this value over here. Okay, Zj minus Cj. Zj minus Cj, just notice Cj is somewhere over there and Zj is over here. So Zj minus Cj, 0 minus 4 will be minus 4. 0 minus 10 will be minus 10. 0 minus 0 will be 0. 0 minus 0 will be 0. 0 minus 0 again, it will be 0. So this is what we are having. This fill-in table that we are having here. It is the initial simplex table. Okay, so now that we have calculated all of this, now we need to find the ratio. So in which part of the algorithm are we in now? Okay, so we have finished up to this part, which is compute Zj minus Cj. Okay, now you need to check this optimality condition, which is condition 5. Zj minus Cj. So you can see that there are some negative values. if there is no negative value here, then we are done. We are done, and this is the solution. Okay, the solution x1, s2, and s3. Okay, the rest of the variables that do not occur here, they are all 0. So x1 will be 0 and x2 will be 0. But now there are still some negative values. Now take a look at that number 6. Number 6 is, it says, choose the most negative zj minus cj. The most negative value, it is this. Most negative. Okay, since this one is the most negative, so this column that we are having here, it will be called as the pivot column. Pivot column. Okay, what will we do now? Now we are in stage. Okay, so we are, which is known as the pivot column or the leading column. Now we will have to calculate the ratio, which is step number 7. Compute the ratios xbi by yir. Okay, xb divided by this column, 50 divided by 1, it will give you 50. 100 divided by 5, 100 divided by 5, it will be 20. 90 divided by 3. Again, how did I get this one? We are dividing this solution by the entries in the pivot column. Okay, so now we have found this one. After finding the ratio, what we will have to do, we will have to choose the minimum ratio. Actually, the ratio should be positive. Okay, do not worry when the ratio is negative. When all the ratios are negative, we will have to do something else. But now, okay, all the ratios are positive, so we will choose the minimum one. Okay, the minimum ratio, it's this. Okay, minimum ratio. So after finding the minimum ratio, this row will now be called as the pivot row. This whole row will be the pivot row. This whole column, it is the pivot column. Okay, so pivot row. Actually, these rows, okay, it is best if you denote it by R1, R2, and R3. Okay, so R2, it is the pivot row. Now this pivot row and this pivot column, they intersect at this point, right? This is the common entry between in the pivot row and the pivot column. So this element over here, 5, it is called as the pivot element. Okay, so up to which stage are we now in? Okay, so we are now in stage number 9. The intersection of the pivot row and pivot column gives the pivot element YKR. So over here, what is R? R, it is the column number. So R, it is equal to 2, the column number. And K, again, it is the row number, which is 2. So this element, it is Y22. Okay, again, R, it's equal to 2 for this stage. And K, it's equal to 2. We don't need to write all this. Okay, but I'm just telling you. What you actually need to write is just to circle that this one is the pivot element. Okay, you need to keep note of that. Okay, so now after doing all this, what we are doing, we have reached up to stage number 9. From stage 10 onwards, we will be requiring a new table. Okay, so the new table, it will look something like this. Again, we can fill in the entries. But now there will be some changes. There will be some changes now. What will we do? Okay, if you notice over here, this pivot column, it is related with x2. x2 will now enter the basis. x2, it will enter the basis. Okay, so instead of the second row, it will now become x2. okay, which is the basis. The remaining rows, they will not change. Okay, over here it will still be S1, and over here it will still be S3. Okay, so now let us fill in this table. CB, now the cost vector will change. S1 it is 0, x2 it is 10, and s3 it is 0. Okay, so now we are filling in the cost vector. Again, I repeat, we are replacing this variable with this new variable in the pivot column. Okay, so this is how we get. Okay, so now what will we do? Okay, if you take a look at this algorithm again, it says now we have done stage 10. We have replaced the variable. We have replaced even the cost vector. Now what will we do? We will convert the pivot element to 1 by dividing the kth row by ykr. Okay, so let's take a look at that. Okay, so now we will apply the operations. We will write over here, after applying the operations in order. Okay, you need to remember to write this one, after applying the operations in order. What operations are we talking about? If you remember, the second row, okay, the second row, it is the pivot row. So R2, over here R2, we will divide R2 by the pivot element, R2 by 5. We will divide it by 5. So if you remember, this initial table, you can fill it from any order. But for the new table, you always remember that you have to first fill in from the pivot row. Okay, so from the pivot row, we will fill it. But we will have to divide it by 5. So over here 2, the initial value, it was 2. The initial value was 2. So now we will divide this whole thing by 5. From here up to the solution. 2 divided by 5 will give you 2 by 5. 5 divided by 5, it will be 1. 0 divided by 5, it will be 0. 1 divided by 5, it will give you 1 by 5. 0 divided by 5, it will give you 0. 100 divided by 5 will give you 20. Okay, so this now is this new second row. Again, this is still the second row R2. Okay, the rows will... Okay, so now that we have changed R2, R1 and R3 will also change. Which operations will... How will we do it? R1, okay, over here it is R1, if you are seeing it, R1, it will also change. It will be R1 minus this element here, it is 1. Okay, so minus 1. Minus 1 R2. This is what we are having. This is what I've written over here. Ri minus something Rk. Okay, this is now step number 12. Okay, similarly, we will change R3. R3 will change to R3 minus this element over here, it is 3. 3R2. So if you notice here, what are we doing? We are using the row R2 to change R3. Okay, so now this comes the tricky part. Okay, this is actually where most of you will make mistakes because it involves a lot of calculation. To avoid any mistakes, this is what I usually do. Okay, once I reach to this stage, I will just take in another piece of paper. Okay, and then I will fill out the elements accordingly. Okay, so let me just take this piece of paper. Okay, so this is a new piece of paper. What I will do is, because now R2 has been changed, R2 will be from this new table, R1 it will be from this old table. Okay, so let us concentrate with R1 first. Let us change R1. So the old value of R1, it is 2110050. 2110050. So I will write it here. 2, I will leave some space. 11050. Okay, now what will I do? I will write this one. Because we need R1 minus 1 R2 minus 1. Okay, so I will write everywhere minus 1, minus 1, minus 1, minus 1, minus 1, minus 1. For some of you who can do it mentally, you can do it. Okay, but I'm very bad at that. Now we need to fill in R2. R2, it should not be from this old table. R2 will be from this new table. So it will be 2 by 5. 1 times 2 by 5 multiply 1 multiply 0 multiply 1 by 5 multiply 0 multiply 20. Okay, so now let us fill in. Okay, so these are the values. Okay, let us calculate them. 2 minus 2 by 5. 2 minus 2 by 5 will give you how much? 5 2 are 10, 8 by 5. So over here, what can we do? Now we can fill in this table based on these values. 8 by 5. Over here will be 0. 1 minus 1 will be 0. Over here will be 1 minus 0. It will be 1. 0 minus 1 by 5 minus 1 by 5. 0 minus 0 will be 0. 50 minus 20 will give you 30. Okay, so this is for R1. Similarly, we can do the same for R3. Okay, let's see. Okay, for R3, if you notice over here the table, it says R3 minus 3R2. R3 again, it will come from the old table. The old table, it is 2300190. 2 from the old table, 2 3 0 0 1 and 90. Okay, minus, if you are seeing here, it says minus 3 R2 minus 3 minus 3 minus 3 minus 3 everywhere minus 3. So now R2 now it will come from the new table. 2 by 5, 3 times 2 by 5. Similarly over here we will be having times 1, okay, times 0, times 1 by 5, times 0, times 20. So this is what we are having. Now let us calculate this one. You will be having 2 minus 6 by 5. You will be having minus 2 by 5. Similarly, over here we will be getting 0, 0, minus 3 by 5, 1, 90 minus 60 will give you 30. Okay, so this is what we are getting. So this is the new table. Now let us again calculate ZJ and CJ. Okay, just let me compare the values with what they've written in the book. 10. Sorry, 5 to 10. 10 minus 6 will give you 4. Okay, minus 4 by 5. So sorry. 2. Okay, just let me see again. Okay, after doing all this, I'm still making some mistakes. 5 2 10 10 minus 6 will give you 4 plus 4 by 5. Okay, over here it should be 4. So sorry, I made a mistake. So just let me compare the answers with what they've written in the book. Okay, just in case. 8 by 5, 2 by 5, 4 by 5. Okay, it is all right. Okay, it is all right. Okay, so now I think we can proceed further. Okay, so now that we have got all this, what can we do? Next, again, we will calculate ZJ. 0 times 8 by 5, it will give you 0, plus 10 times 2 by 5. 10 times 2 by 5, it will give you 20 by 5, 4. It will give you 4, okay, plus 0. Again, similarly over here will be 10. 0 times 0 will be 0, plus 10 times 1 will be 10, plus 0 times 0. So 0 plus 10 plus 0 will be 10. Similarly, 0, 0, 0 will be 0. Over here we will be having 0, 2, 0, so it will be 2. And over here will be 0, 10 will be 0. So this is what we are having. Again, now we can calculate Zj minus Cj. Zj minus Cj will be 0, 0, 0, 2, and 0. Okay, so this is what we are having. Okay, now if you take a look at the table, at the algorithm, it says that now all of them, there are no negative values. If there are no negative values, so the table ends right here. Again, there are no more negative values here, so that is why it ends over here. Otherwise, we will have to fill in a new table, calculate the ratio, find the pivot entry, find the pivot column. Okay, we will have to do all that. But now we are lucky, since all of them, they are not negative, we can end it over here. So from this part onwards, what we can do is, we can say, hence, since all Zj minus Cj, they are greater or equal to 0, therefore, the solution is, okay, what is the solution? Over here, S1 is 30, x2 is 20, S3 is 30. The solution is x1. x1, it does not appear here, so it will be 0. x2, it will be 20. x3, S1 will be 30. S2 will be 0, and S3, it will be 30. Okay, and the maximum Z, okay, just fill in the values in the objective function. 4 x1 plus 10 x2 plus 0 s1 plus 0 s2 plus 0 s3, which is equal to, okay, 10 times 20 will give you 200. Okay, so this is the final solution. Okay, this is the final solution. So this is how you do the simplex method. Until next time.